Alright guys, we're out in the shop and we're just flat screwing around tonight. Alright guys, welcome back to the channel. Tonight we are going to work on a requested video. I got an email from our friends at Arccaptain and they reached out to me and asked if it would be possible to do a video using the MIG 205 MP, specifically this machine, because there are some customers out there that are having a hard time getting this machine dialed in to the sweet spot. So we're going to see if we can find the sweet spot tonight. So I've got a couple pieces of 10 gauge here and I've got my machine set up. I got the gas hooked up. So in my opinion, one of the best ways to learn how to get good at welding is probably running short arc. And when you run short arc, you use C25 gas or C10, whatever you prefer. I prefer C25. So we've got C25 gas hooked up. We're running about 20 to 25 CFH. I've got my machine ready. It's set up for 10 gauge and I want to show you guys how I got to this point so far. We're going to check out our chart in the machine here. The charts in the machines are just a reference point and it's a great place to start, but that's probably, very rarely is that usually the sweet spot. So let's take a look at the chart. So we know we're running solid wire. And we know we are running mixed gas. Okay, it tells you what the flow rate should be between 17 and 25 CFH, so we're good there. I'm running 030 wire. Okay, and then I'm going to be welding with 10 gauge, which 11 gauge is close enough. Okay, so that tells us that we need to be at 20 volts, 460 inches a minute. 20 volts, 460 inches a minute. And you can see we're on MIG right there. We should be all set up. Now, so to start out, we're going to run just regular short arc MIG. And then we'll turn pulse on and see what the difference is. There was a specific request to see if we could find the sweet spot on pulse as well. So we'll start with just regular MIG. We'll see how it goes. So starting out off of our chart with our machine set to those settings, let's see how she does. Okay, here we go. Let's get a tack on this. So let's just start on one side and weld to the left, maybe 2 inches. Let's see how this goes. Okay, it's not bad. It's not bad, but you can see it's just a little bit humped up. I felt like the amperage was good, but to be honest, I felt like the wire speed was maybe a little bit fast. So let's try turning it down. So let's go down to 425. Okay. Now I'm going to leave a little bit of a gap and I'm going to run another 2 inches here. Okay, so there wasn't a whole lot of difference there. I did just turn my wire speed down just a little bit more. Now we're at 380. Let's see how it runs. Okay, we're getting there. Hopefully you can see the difference between that one and the one before it. This one's a little bit flatter. That's how I like it. Now I realize that everybody's a little bit different, but hopefully you could hear the frequency change or the tone. It kind of smoothed out. So the first two welds were more crackly. I like more of a hum, so the crackle will kind of smooth out when I find that sweet spot for me. Okay, so I'm at 380. I want to drop it down another. Let's go 360 and see what it looks like. Okay, so now we're 20 volts and 360 inches per minute. Okay. Ooh, I'm liking it. Okay. See that one? You can see it's not near as humped up as the first one and the second one. Third one got a little better. Fourth one's even better. And I really like the way that one ran. So, I'm pretty happy with that. Now, that's quite a bit different than the parameters that are on the chart. The parameters on the chart would work great. I'm not saying they wouldn't, but it's just not what I would prefer. I like a little bit more heat, a little bit less on the wire speed, and that kind of smooths things out a little bit. So I'm pretty happy with where that's at. So I would say that's a good reference point if you're welding 10 gauge. But this process will work for any thickness on that machine. So if you're welding 14 gauge and you start there welding from the parameters on your reference sheet, start there. If it's the same way, if it's all humped up, that could be two things. Usually if the weld is humped up, it means you're feeding rod too fast or you're too cold. One of those two things. You could probably adjust it either way and it will do the same thing, but with material thickness you want to be dialed in so that the heat is hot enough to make a good fusion weld, but dialed in to where it runs smooth. It makes a difference in what the weld looks like, and it makes a difference in the quality of weld you get as well. So I guess what I'm trying to say is start with the reference sheet, and then you need to start playing with it up and down, wire feed speed and heat. Get yourself a couple pieces of scrap and get it really dialed in. And then well, this is where I like it. Okay? So I'm going to flip this over, and now we're going to turn pulse on. So there's straight current, there's pulse. Okay. So with pulse, right now it's at 23.7 volts and 150 amps. And I don't know if it gives you any parameters for pulse here. Let's look. Okay, so I'm going to drop this down. Let's go to 20 volts. Let's see what that gives us on amperage. Okay, there's 20 volts. That gives us 87 amps. And it looks like you can adjust hard and soft. And then you can see over here it's got pulse on. And then on peak amperage it looks like we're getting 23.3 volts. And I'm guessing at the bottom of our wave, of our sine wave, we're getting 20 volts. So that's the point. Anyway, that's what it looks like I'm seeing there. Let's try it. So usually the only time I use pulse is if I'm welding something really thin, and that's where pulse shines. Basically what you're doing is you're ramping up the voltage and then you're dropping the voltage, and it just sits and goes up and down. The reason you use that is because it gives you a good fusion weld while putting a minimal amount of heat into something so you get less warpage, hopefully. So let's run one here and we'll see how this goes. So here's 20 volts, 87 amps on pulse. Okay, I can already tell that's way. So I'm gonna go up, and I don't know. Well, sync's on. Let's change sync. Let's really play with this. Let's go 22 volts. That's 120 amps. Okay, so hopefully you guys can hear that's turning into more of a hum. Less crackling. I'm gonna go up some more. Let's go to 23 volts. Let's see what that does. Still getting quite a bit of spatter. So I'm hoping we can get this dialed to where we're not getting such a mess. Definitely better. So there's the first one, way too cold. There's the second one, a little bit better. There's the third one, we're getting there. And hopefully you can hear the pitch difference. Okay, so let's go up to 24 volts. Okay, here we go. Okay, that ran pretty dang good. I like the way that ran. We're still getting some crackle. I think I might have had the wire thickness setting wrong. So let me grab another couple pieces of scrap and we'll try it with this setting. Okay, it's running pretty good. Oh, okay. Okay, so I just figured something out. I want to show this to you. So there's the interface on our machine. Now, you got your voltage here, you got your amperage here. You can see it's in sync mode, and I can't get sync mode to turn off for some reason. So, right here where the voltage is, if I go to adjust this, you can see it's plus or minus. So it's actually going to adjust. You can actually adjust it 0.1 increments. If we get drastic, I want to see what it does. So if I adjust my voltage, I'm able to adjust them separately. So I'm going to try 24 volts and 135 amps. Here we go. Now let's see if that crackle and all this spatter gets any better, because I don't really care for that. I think that should be a lot better. Okay, I can already tell we're not feeding it enough wire feed. So let's go. I want to go up on my wire feed speed, and I want to go down on my heat. So I'm going to go all the way up to 380. Let's go 385. 385. Okay. And then I'm going to go down on my voltage. So that's okay. Okay, I see what it's doing here. So now that I've adjusted that, it's gone all the way to the hard side of the scale. So this should be a harder arc versus a soft arc. So let's see how this looks. Okay, we're still not feeding it wire fast enough. So we need to go up on our wire or down on our amperage. Let's go down. Let's go to the soft side this time. Let's try this again. So now we're 23 volts, 136 amps. We're all the way to the soft side of the scale. So let's see how this runs. Okay, so here's what I've learned. If you push this button, there is your inches per minute. They are synced up, and I don't believe there's any way to change that. If I hold sync down, it doesn't change. Okay, so we are on pulse and we are synced up. So when you adjust your amperage, it's going to adjust your voltage. When you adjust your wire feed speed, so if I hit that button, it goes to wire feed speed. If I adjust that, it's synced up with the voltage. Okay, so to get that dialed in, what you'll have to do is you'll have to go on your voltage, find your sweet spot, whatever you like. 21.5, let's go with that, okay? And then you can see it goes back to your amperage. The other thing you can do to try to get it dialed in soft and hard to find the sweet spot is you hit this button and you can go 0.5 up. You can go anywhere from 1 to 10, and I believe that's volts. It might be in 0.1 increments, but you can go positive or negative, and that will adjust your hard and soft. So that will give you a little bit of variance so that you can try to get this tweaked, since they're synced all the time. So let's go 20. So I'm just going to go 21.5. So if I go up 5 on the volts and let's go 0.5. Okay, so that's on the soft side of the scale right there. Okay, so that's going pretty well for pulse. I mean, so the other thing I want to show you, if you hit this one twice, there's 18 gauge. If I go up with that, there's 16 gauge. Keep going up. Okay, so the high end for 16 gauge is 25.4. In my opinion, that's going to be way too hot. But the point of this is to try to keep as much heat out of it. And so if you were trying to weld something that was that thin, it's going to keep as much heat out of it as possible while still giving you a good, strong weld. Go to your material thickness, scroll this down, and you'll see your voltage drop. And there it changed to 18 gauge. So that'll kind of give you an idea too. Because the main reason you would use this is if you're welding on thin material. That's why it says 18 gauge and 16 gauge. So obviously I'm running this on a piece of 10 gauge, which is not ideal. But you can see the last one we did was right here. And there is some mill scale on there, but it's a good looking weld. I didn't like how hot that one was. I didn't like how cold that one was. And I really liked how this one ran. But again, that's on 10 gauge. And if you're running on thin material, you're just going to have to play with that and see what you like. And you're going to have to adjust the hard and soft by hitting this button and going up or down up to 1.0 in either direction. Hopefully that makes sense to you. But that's how I would get it dialed in if I was welding something thin and I wanted to use pulse. Like I told you guys before, I don't use a lot of pulse. Typically, if I've got to weld something thinner, I will use TIG. That's just what I prefer. If you don't want to waste all the time, you can still run short arc, straight voltage instead of pulse. You can still get pretty good results welding it straight. But the option is there if you want to use it. So I hope this helped somebody out. And when it comes to dialing in a welder, it's as much about listening as it is about anything. So you want to listen for that crackle. If you're getting too much crackle, like I said, you're going to want to either slow down your wire. You just need to listen to the crackle. And you need to be able to read the weld. You'll be able to see the wire. If the arc is jumping before the wire gets to the puddle, you should be able to tell, okay, I need to turn up my wire feed because I can see the arc jumping from the puddle to the wire. If it's too fast, if your wire feed speed is too fast, it's going to crackle like crazy and it's going to have a lot of spatter. Maybe try throttling that back down a little bit. And then playing with your heat. I like looking at the weld and seeing how much it's humped up. If it's really humped up, it's too cold. If it's too hot, sometimes it'll be dished, and when you finish up your weld, the fisheye that's left, if it's kind of concave, then it's a little bit hot. I like it to be about flat in the corner. That's about where I like to run it. No matter what thickness I'm running, you can dial that in and find that sweet spot to where the weld looks the way you want it to and it's giving you the penetration you need. So hopefully that helps. That's what I would do to try to find the sweet spot for you guys that are getting started, that you're having a hard time trying to find that sweet spot. That's what I would do. I would run it, listen to it, try to follow the things that I just told you about how to know whether you need to dial in your voltage or your wire feed speed. And if you just play with it back and forth, eventually you're going to find that spot. Don't play with both at the same time. I would play with one or the other. And then if you feel like, let's say you get the wire feed speed dialed, if you feel like the voltage is too hot, once you get that dialed in, you're going to have to drop that down a little bit, and then you might have to go back and tweak your wire feed speed. It's kind of a game sometimes of trying to find that sweet spot. So hopefully that helps. I think you guys should be able to get it figured out if you use that method. Give it a try. Let me know in the comments. I hope it helped somebody out. Thanks for watching as always. See you on the next one. Now, in my opinion, the best way that you're going to be able to find, and we know we're running mixed gas, goodness, gonna need a ground.